Hi everyone, and welcome to a presentation titled Project Safe Supply. We are 4 students, Autumn Chen, Eunice Leung, Rianne Lee, and Sasha Mazzarello, from the University of Toronto. We worked on a quality improvement project to improve the supply chain management of backordered and defective medical and surgical disposable supplies at the Hospital for Sick Children. In this presentation, we will describe the background, objective, and methodology of this project. We will also describe the development of 2 PDSA cycles and discuss the results and planned evaluation of this project. In 2017 to 2018, the Process Improvement Team worked on supply chain optimization to manage challenges with disposable medical and surgical supplies. These challenges included backordered items of high-use supplies critical to treatment delivery, expired supplies on units, and supply defects and malfunctions. The project was extensive, and their work highlighted multiple opportunities to improve the off-site warehouse system, which is Cardinal Health, a third-party vendor. Spread and sustainment of the recommendations has yet to occur. Stores, which is an area of the hospital that scans, orders, and stocks items, was working with Cardinal Health to ensure supply security by adjusting inventory management parameters and identifying critical item lists. When issues arise, central supply chain staff, local teams such as educators, managers, and quality leaders, and the executive are involved in problem identification and resolution. Despite these efforts, significant process and communication-related problems continue to occur. Given these supply challenges resulting in potentially harmful events, our goal was to improve the communication and escalation process for backordered and defective medical and surgical disposable items by May 2020. Specifically to reduce the number of communication errors and increase the competence of staff by increasing the rate of compliance when issues occur. We reviewed safety reports over a period of 6 months to determine report eligibility. We developed 2 Plan, Do, Study, Act PDSA cycles, conducted a visual stream map to understand stakeholders' perspectives of processes, including timelines of each step and workflow, and we shadowed and observed the stores department. Our first PDSA cycle is on frontline staff reporting. The initial step to this PDSA cycle was to collect data on how staff were reporting the defective or backordered supplies, how the information was currently reported to the respective quality leaders in stores department, and what roles were required or fulfilled in this reporting process.
In the first Do section of our PDSA, we had a member from Quality Management pull 6 months' worth of safety reports from May to November 2019. All the reports were filtered so that they only include issues with equipment. We manually went through the data to gain an understanding of how staff members were reporting these incidents. We then were able to separate the data by location of the event, type of equipment, description of the event, and severity. From here, we identified several opportunities to improve the safety reports that my colleague will address later in the presentation. One of the highlights of the Do section was conducting a VSM, or Value Stream Map. The VSM was an excellent visual for us to collaborate with front-end users to gain an understanding of the complete process for defective and backorder supplies. There were representatives from different departments providing their input on what was real work versus imagined work. In addition, stakeholders could determine any tacit knowledge that was not identified in the initial process. It gave us the opportunity to visually determine areas of improvement. So how was this facilitated? There were 5 categories that were established for the mapping process. Key processes in yellow, confidence level in orange, additional information in the lime green, time between steps in the pink, and opportunities in the blue. Our supervisor acted as a facilitator and asked all the involved parties to list out the steps of the key process. Once the steps were identified, additional information was added, such as tacit knowledge or other information that people not directly involved with the process wouldn't understand. This was followed by the level of confidence at each step, the time it took for each step, and finally the areas that could be used for improvement for opportunity. In the blue section, you see that the participants voted for what they thought would be the best to improve with the stickers. Everything was written on sticky notes to allow the facilitator to move the pieces around during the mapping process. Our final VSM looks something a little like this, and it was transcribed electronically for storage purposes and for future use. So from here, we were able to determine what was the most feasible and popular option to deploy or fix, as highlighted by the rectangle, and we'll go into that in a little bit. Our final component of the Do section was shadowing the store's staff. We did this to better understand the workflow surrounding backorder or missing supplies, to observe the physical layout that affects these supplies in the clean rooms, and to understand how frontline staff identify defective or backorder supplies. Now my colleague will go into detail about what we acted upon.
Now that we covered Do, what did we find? This is where the study part of the PDSA cycle comes in, and we began with our data analysis reports. From all the reports we pulled and categorized, we saw that 75% of equipment failures were attributed to defective products. Missing and backordered products took a much smaller portion in comparison. Now that we covered what we did, let's talk about our findings. This is where the study part of the PDSA came in, and we began by studying our data analysis reports. From all the reports that we pulled and categorized, we found that 75% of equipment failures were attributed to defective products. Missing and back-ordered products took a much smaller portion in comparison. Data analysis also revealed insights on the types of problematic equipment. Infusion and transfusion products like tubings and caps were the most problematic, accounting for up to 41% of reports. Vascular access products like needles and catheters followed second. But perhaps more interestingly, data analysis revealed patterns about the reporting system itself. A lot of the reports were miscategorized or incomplete, apparently made in haste by the staff doing the reporting. We found many reports that were really caused by user mistakes rather than equipment issues, but because an equipment was involved, the person doing the reporting ended up categorizing it as equipment failure. A lot of reports were made about EMRs, computers, and sometimes even fridges and cabinets, items that can be easily interpreted as medical devices, but ended up adding a lot of noise to our data, which is supposed to be on just disposables. And even when reports were properly categorized, we noticed that in most cases, important information such as lot and bin numbers were either not reported or reported in non-standardized ways, which again makes it harder to scale up investigations on the failed supplies. Lastly, we studied the supply chain VSM, which ended up being really large, spanning many departments and processes as you saw earlier. All the stakeholders together identified many opportunities for improvement, but the process of creating this VSM really helped us narrow down the scope of our project. As part of the QI team, there are certain areas that we don't have control over. But within our scope, we were able to identify a key opportunity for improvement, which is to standardize the process for equipment safety reporting. As you can see in the diagram here, the green circles each represent a vote from a stakeholder. All stakeholders in attendance were given 3 ballots to vote for what they believe is the most critical opportunity to act on, and standardizing the equipment safety reporting was one of the 2 opportunities that received the most votes. It is within our scope, and the need for this change is very consistent with what we found and talked about in our data analysis findings earlier as well. With these findings in mind, we moved on to the next phase of ACT, specifically acting to redesign and improve the usability of the safety reporting system. On the right side here, we have attached some screenshots of the current safety reporting system interface, from which we've made a few recommended changes. Let's start with number 1. After a user decides to make a report, they should first be greeted with a question that broadly asks them if there is an equipment malfunction or unavailability issue. As you can see from the box label number 1, there is already a similar question in the current system, but there are 2 problems associated with the way it's set up right now. First, it's too far down on the page after a bunch of other equipment-related questions have already been asked, which doesn't make sense. Second, this question asks if there are equipment/supplies involved or malfunctioning. The word involved here is confusing because it prompts many users to select yes just because they interacted with an equipment, even if it's a perfectly functional one. This, of course, muddies our equipment data and hurts our downstream communication. Therefore, we recommend removing the word involved and making the question explicitly just about malfunctioning or unavailable equipments. Moving on to number 2. Let's say now the user has said yes, there is an equipment malfunctioning or unavailability event. Now they should be able to further narrow down the specific event type. As you can see in the box label number 2, this is currently doable via a drop-down menu, but the language used here is not very clear. For example, the drop-down lists both broken item and equipment/device malfunction, which are very similar in meaning. The drop-down also lists outdated item, which may or may not mean expired. Again, it's not very clear to the end user. So we recommend first stratifying the drop-down options into only 3 categories: missing, defective, and expired product. Then we can apply branching logic to each category. For example, if a user selects defective item, they can further specify what exactly is defective, such as sterilization or cleanliness issues. Our third suggestion is to auto-populate the equipment details section as soon as the user confirms that there is an equipment issue, just to make it a little bit easier and less work for the end user. Currently, they have to manually click on a button to open it. Our fourth recommendation is to clean up the item category dropdown, which is where the user can specify what kind of equipment has been problematic. If you look at the drop-down options closely, choices like health IT systems is confusing and should not be here because there's actually a completely different reporting category for IT system issues altogether. So this option should be completely removed from this drop-down that's only meant to apply to medical supplies and equipment. Our fifth recommended change is to eliminate the equipment notes section. This is because there is already another free text box in a different section of this report that asks for a detailed description of the event. The other box is not shown here, but there are no discernible differences between the two sections, and there's no reason to keep both other than to confuse the user. Another important change we want to propose is to make it easier for users to add stores number and lot numbers. These two numbers are essential to identifying problematic supplies, but currently there is just one combined entry field for users to submit both numbers. The word choices used here is also confusing because words like control number or asset tag are not commonly used terminology amongst the hospital staff. So we recommend separating this text field into two fields, one for stores number and one for lot numbers, as well as adding a hover over FAQ to help users understand why this is important and where to find these numbers. Lastly, to help facilitate communication with the backend managers who receive these safety reports, we recommend adding a field where the reporting user can choose a specific management role to submit the report to. Another hover over FAQ here would be helpful to explain why. These are our recommended changes. With our champions' help, we were able to take these recommendations to the IT department at SickKids. Most of the proposed changes were actually doable, but unfortunately because of COVID, this project took a back burner. We look forward to seeing the revised interface after COVID and go from there.
While PDSA 1 focused on redesigning the safety reporting system for frontline staff, PDSA 2 was dedicated to report owners and quality leaders. Now that we had revised the interface for the safety reporting system, we needed a standardized method for the quality leaders to communicate the problems at a systemic level. The team was introduced to the supplier corrective action report method, termed the SCAR matrix, by another staff member from a different department, and found the matrix could be easily adapted to fulfill the goals of PDSA 2. The SCAR matrix will help determine the level of escalation required when problems relating to defective and back-ordered products arise. A meeting was held with the quality leaders and the steering committee to discuss collectively agree upon definitions for severity and frequencies. Unfortunately, due to the situation around COVID-19, work on this project was placed on hold, but ideally the final modified SCAR matrix would be embedded into the safety reporting system to aid decisions regarding escalation. Nevertheless, a standardized template for communication was developed and a sample post could be seen on the next slide. a photo of the product, a brief description of the problem, where it occurred, and what was done is summarized with the SBAR framework, which stands for Situation, Background, Assessment, and Recommendation. The Hospital for Sick Children has already adopted SBAR as an effective communication method, so we reasoned that it would be equally effective within this context when reporting issues with medical surgical disposables. In the study phase, we would have liked to analyze feedback from quality leaders and the steering committee to determine if the SCAR matrix is valuable to include in review of reports. We would introduce scenarios and see how the team would categorize various reports to understand the effectiveness and usability of the matrix. Finally, the formalized decision matrix would be incorporated in the safety reporting system, and a standardized template would be shared via a Microsoft Teams channel to consolidate communication in one area with all team members versus the current medium of email communication. This project has resulted in several outputs based on the opportunities for change identified from the value stream mapping exercise. To summarize, we redesigned the interface of equipment safety reports, decided to standardize escalation with an adapted decision matrix, and created a Microsoft Teams template to centralize equipment issues. Our planned evaluation strategy post-COVID-19 is to interview quality leaders regarding the usability of the new interface and the decision matrix, to calculate the number of new safety report issues after our changes, to compare matrix prior to QI project initiation, and complete the unfinished components of PDSA2. This is the QI team on Project Safe Supply, and we would like to thank the listeners for your interest in our project. We would like to acknowledge Andrea McCormick, Manager of Quality Management, for her leadership and guidance throughout the project, the Hospital for Sick Children for providing this wonderful learning opportunity to impart real change, and the University of Toronto Institute for Healthcare Improvement for linking us to Project Safe Supply.